All right, hey guys. Before we get started with the lesson, I want you guys to take just about 5 minutes and work on this bell work. So pause the video for 5 minutes and then come back and I'll go over it. Okay. So you should have worked on the bell work. This is a question that is like what we did in 1.5. So we're talking about two different linear situations, gym A and gym B. Gym B is represented by this equation, and gym A we have a table for, so we have to find the equation for it so we can compare the two situations, right? So for gym A, we're going to use y equals mx plus b. The first thing I need to find is my slope, m. So I'm going to find the change in y. So from 28 to 40, I'm going up 12 over the change in x. So from 2 to 5, I'm going up 3. So if my slope is 12 over 3, I can simplify that to just be 4. And now I want to find b. So the way that I'm going to do that is I'm going to plug into my slope-intercept form. I'm just going to use my first point, 2, 28. So I'm going to replace y with 28, m with 4, x with 2, and then I'm leaving b because that's what I want to solve for. So 28 equals 8 plus b. Subtract 8. That means that b equals 20. So my equation for gym A is y equals, my slope is 4, x plus my y-intercept is 20. Okay, so now I have two equations that I can compare. The first thing I want to do is just identify what slope and y-intercept stand for. So slope in this situation, if we're paying to go to a class at a gym, my slope is cost per class. Or you can also think, what's y per x? My y-intercept, that's the thing that doesn't change. So it's what you're paying no matter what. So I would say that would be called like a gym fee or like a registration fee maybe. All right, so when it asks which gym charges less per fitness class, I'm looking at the slope. So between gym A and gym B, gym A you pay $4, gym B you pay $5. So the answer to that question is gym A. And then after how many fitness classes are the total costs the same? So I'm going to set my equations equal and see when they match. So 4x plus 20 equals 5x plus 10. And then I'm going to solve this equation. So I'm going to subtract 4x from both sides, and I'm also going to subtract 10 from both sides. So 20 minus 10 is 10. 5x minus 4x is just x. 10 minus 10 cancels. So that means that when I have 10 fitness classes, gym A and gym B cost the same. All right, moving on. So today we're talking about 1.6 and 1.7. 1.6 is all about absolute value functions. It's very shortened because your book has a lot of extra fluff. And then 1.7, we're talking about piecewise functions. All right, so starting with 1.6, we're talking about absolute value functions. Absolute value functions are any function that has an absolute value expression in it. When we're working with an absolute value function, it's always going to be in the form g of x equals a times x minus h, or times the absolute value of x minus h plus k. That's called vertex form because your vertex comes directly out of that form. So that's the x value of your vertex, that's the y value. Notice, because that h has a minus in front of it, that's going to have an opposite sign. Since the k has a plus, that'll be the same sign, which you'll see in the example. And then also, you need to know, absolute value functions they look like a V, right? They look like this. So your vertex is down here. They are symmetric about the line x equals h, which is just the line that goes through the vertex. So that means that anytime I'm graphing, if I can graph one side, the other side is literally just a mirror image over your vertex. So for example 1, graph f of x equals absolute value x minus 4 minus 1. The first thing we're going to do is we're going to identify our vertex. So again, we're looking here and here. Opposite sign, same sign. So we'll have positive 4, negative 1. And we're going to put that in the middle of our table. Once you have your vertex in your table, you're going to fill in your x's just numerically. So behind 4, I'm going to have 3 and 2. And above 4, I'll have 5 and 6. To fill in your table, you're going to have to plug in your values. So the first value, x, is 2. I'll plug in 2. So absolute value of 2 minus 4 minus 1. We simplify by starting with the inside of the absolute value. So 2 minus 4 is negative 2. And then we actually take the absolute value. So that's 2 minus 1, which is just 1. Then we're going to plug in our next x value, 3. So absolute value, 3 minus 4 minus 1. Simplify the inside. It's negative 1. And then take that absolute value. So 1 minus 1, that'll be 0. Now this is why it's important that you remember that we're symmetric, because that means you can just carry over your points and not plug in your other two values. All right, now we're going to plot our points. So my vertex is at 4, negative 1. Then we have 3, 0, and 5, 0. And then we have 2, 1, and 6, 1. And I'm going to draw my graph. And you want to draw it as straight as possible, so you might need to go through more points, or you might need to use a straight edge. But that'll help you see all the characteristics that you need to see. All right, so that is our f of x. Okay, so the first thing that we are talking about is going to be positive and negative. So positive, when I say that my function is positive, I'm talking about when it goes above the x-axis. So when I look at my graph and I'm looking at above the x-axis, I'm looking at this part of my function and this part of my function. So I'm going to identify those intervals. So this is when, for the left side, that's when x is less than 3. So from this point backwards. Okay? And it's also this point forwards, which is when x is greater than 5. Okay? Negative. So if positive is above the x-axis, negative is when we're below the x-axis. So we're looking from here to here. So the way that we'll word that interval is we'll say when x is between 3 and 5, right? And the way you write that as an inequality is 3 is less than x, which is less than 5. Okay? I'm going to erase this part. The next thing that we're going to talk about is increasing or decreasing. And I'll use a different color here. let's use pink. So increasing, when you think of an absolute value function, you can think of it like a V, which you can also think of like two different lines, right? So increasing is the line that has a positive slope. So for this function, the line that has the positive slope is the line on the right side. This line is going up. And so that's when, right here onward, so when x is greater than my vertex at 4. Okay, decreasing, that's going to be the opposite. That's our line that has a negative slope. So that's this part of my function right here, the left side. Okay, so my interval for that is when we're going to the left. So that's when x is less than my vertex 4. Okay. Now the last characteristic that we need to know about absolute value functions is the end behavior. So when we talk about end behavior, we're talking about the two tails of the function. The first one we say as x approaches negative infinity. So when I say x approaches negative infinity, that means I'm going to the left, right? So I'm looking at this tail and I'm looking where it's pointing. And so since it's pointing up, I'm going to say that y is approaching positive infinity. I'm going to run out of colors here soon. All right. Then you look at the other tail. So as x approaches positive infinity, that's the right side. Looking at this tail. Again, this one is facing upwards, so that will also be y is approaching positive infinity. If it were facing downward, it would be negative infinity. All right, so that is our example for describing the characteristics. Go ahead and work on the next two practice problems. Pause the video for just 5 minutes. You might not get done, but we'll come back together. So just pause for 5 minutes and then come back and check. Okay, you've taken your 5 minutes, so let's go over our practice problems now. So graphing number 1, my vertex is at the point -6, +1. So that is the middle point of my table, and I'm filling in accordingly. And now I'm going to plug in those values. If you're running out of space on your paper, you can use the back of this page. All right, so -8 + 6 + 1, that's -2, which becomes +2, so that will be 3. And then we have -7 + 6 + 1, so -1, which becomes +1, which is 2. And then we mirror our points in our table. All right, since my vertex is at -6, 1, I want to have this quadrant showing. All right, so I'm going to plot my points. -6, 1, and then on either side, -7, 2, -5, 2, and then -8, 3, -4, 3. All right, so first we have positive, negative. For this one, the entire function is above the x-axis, so we're going to say that it is positive for all real numbers. And when I say all real numbers, it's because there is such thing as imaginary numbers, but we don't know what they are. So don't worry about that right now. Just know that that means that it's positive for the entire function, basically. You can also use this symbol for all real numbers. Okay? If it's positive the whole time, there's no interval where it's negative, so I can skip that. Increasing, the line that has positive slope is the line on the right, so that is when x is greater than my vertex at -6. Decreasing, the line that has negative slope is on the left. That's when x is less than my vertex at -6. And then end behavior. So on the left side, as x approaches negative infinity, my tail is going up, so y is approaching positive infinity. On the right side, as x approaches positive infinity, my tail on that side is going up as well, so y is approaching positive infinity. All right, that's it for practice 1. Second practice problem. My vertex is at the point 5, 2. So my middle point in my table is 5, 2, and I'm filling in around the 5. And now I'm going to plug those in. So first I have negative absolute value 3 minus 5 plus 2. That's negative absolute value negative 2 plus 2. So absolute value makes that positive 2, but it has that negative in front of it. So it comes out to be 0. Okay, then we have 4. Negative absolute value 4 minus 5 plus 2. Simplify your absolute value first. And then we have negative 1 plus 2, which is just 1. And remember to mirror your points. Okay, so my vertex is at 5, 2. All my points are positive, so I'm going to put this first quadrant here on my graph. And I'm going to plot my points. So first, my vertex at 5, 2. And then around it, I have 4, 1, and 6, 1. I went the wrong way. My bad. There we go. 4, 1, and 6, 1. And then 3, 0, and 7, 0. And then we connect. So first we have positive. So I'm above the x-axis from here to here, right? So when x is between 3 and 7. So we'll say 3 is less than x, which is less than 7. Negative, we're below the x-axis. On the other sides of that, so when x is less than 3, and when x is greater than 7. Increasing, my line that has positive slope is the left one on this one. So that's when x is less than my vertex at 5. Decreasing, the line that has negative slope is on the right side. That's when x is greater than my vertex at 5. And then end behavior. So as x approaches negative infinity, the left tail is pointing down, so y is approaching negative infinity. As x approaches positive infinity, the right side is pointing down, so y approaches negative infinity. Okay, example 2, modeling real life. So we have this function here. Before we talk about this example, I've got to explain a little bit just in case you don't remember or have never learned it. Absolute deviation, you might want to make a little note. Absolute deviation just means how far a point is from the average. All right, so the function m of x equals absolute value x minus 179 represents the absolute deviation, so how far each point is from the average, of a man's height x from the average height of men in Tennessee. Okay, so m is my men's. My y represents the absolute deviation. My x represents the height. Okay, next sentence, the function w of x equals absolute value x minus 163 represents the absolute deviation in centimeters of a woman's height x in centimeters from the average height of women in Tennessee. So again, w of x is women's, my x and y represent the same thing. So y is absolute deviation, x is height. So interpret and compare the vertices of the graph. So for the men's, the vertex is at the point 179, 0. For the women's, we're at the point 163, 0. Now my vertex, this is when my height is 179 for men and 163 for women. And my absolute deviation is 0. If my absolute deviation is how far a point is from the average, that means that this is the average. So to interpret, we're going to say the average height of men in Tennessee is 179 centimeters. And women in Tennessee is 163 centimeters. To compare, that's as easy as it looks. Men's is higher, right? So men in Tennessee have a higher average height than women. And I'll give y'all just a couple seconds to finish writing. All right, part B. Compare the absolute deviations for a man and a woman who are both 171 centimeters tall. So we have to find the absolute deviations. We're given the height, which is our x. We're going to plug that into both equations. So for men, when I plug in 171, that's the absolute value of 171 minus 179. So simplify, that's negative 8, which the absolute value of that is positive 8. For women, when I plug that in, I've got the absolute value of 171 minus 163. When you simplify that, that's positive 8, which the absolute value of that is positive 8. So my absolute deviations for a man and woman who are both 171 centimeters tall, they're both 8 centimeters off of the average. So again, they are both 8 centimeters away from the average height of their gender. All right, so that is it for 1.6. That is what you need to know about absolute value functions. 1.7, we are talking about piecewise functions. Piecewise functions are exactly what they sound like. They are functions consisting of multiple pieces of other functions. So they're defined by two or more equations. Each piece applies to a different part of its domain. So when I say domain, I'm talking about the x values. So each piece has a different x value that it's assigned to, or set of x values. So looking at this example function, we've got f of x equals x minus 2 if x is less than or equal to 0, which I'll highlight here for you. That's this line. And then we have 2x plus 1 if x is greater than 0, which is this line right here. So x minus 2 represents the values of f when x is, we're looking at when x is 0 and below. Okay, 2x plus 1 represents the values of f when x is. We're looking when x is larger than 0, so above 0. Notice how this does not have the equal to symbol, and it has an open circle at 0. So that means that this one is not including 0. So make a note right here. If it has the equal to, so less than or equal to or greater than or equal to, it's going to have a closed circle and it's going to include that point. If it does not have the equal to, so it's just less than or greater than, it's going to have an open circle, and it does not include that point. That point is just a starting point for that line. Sorry for my dogs. All right, example 1. So we have two things that we can do with a piecewise function. We can evaluate it, or we can graph it. The first thing we're going to do is evaluate. With evaluating, you have to know which equation you're working with. So what you're going to do is you're going to look at, let me not draw a line through it. You're going to look at these intervals right here to determine which equation to use. So for part A, when x equals 2, I'm going to look and see which interval that falls under. So x equals 2 is going to fall under x is greater than or equal to 2. So I'm using the pink equation or the second equation. So I'm using f of x equals x minus 5, and I'm plugging in 2 for x. So f of 2 is 2 minus 5. 2 minus 5 is negative 3. So that is my answer when I plug in x for 2, or 2 for x. Okay, part B. When x equals negative 1/3, that's going to fall under x is less than 2. So I'm looking at my yellow function, my first function, or equation. So I'm looking at f of x equals 3x plus 1. And I'm plugging in negative 1/3 for x. So 3 times negative 1/3 plus 1. When you simplify that, you're going to get negative 1 plus 1, which is 0. So evaluating, you have to look at the interval, determine which one it falls under, and then use that equation. So take 1 minute and work on these practice problems. Pause the video for 1 minute. All right? I'm going to go ahead and label my intervals just so I can keep up with this. But you're checking your answers now. Part A, when x equals -6. -6 is less than -2. So I am using my first equation. And I'm plugging in -6. With a constant, there's no x to plug it into, so 3 is just going to be my answer there. All right, part B. X equals 0, that's going to fall in my second interval between -2 and 5. So I'm using my pink equation, or my second equation, which is f of x equals x plus 2. And I'm plugging in 0. So 0 plus 2, which is 2. And then finally, when x equals 8, that falls under the interval x is greater than 5. So I'm using my last equation, f of x equals 4x for this one, and I'm plugging in 8. So 4 times 8. And that's going to equal 32. All right, so like I said earlier, the next thing that you can do with a piecewise function is graph it. The way that I'm going to graph it is I'm actually going to graph the entire line and then erase the part that I don't need. So we'll start with this first one. Here, I'm not going to use yellow. Use pink. All right, so I'm graphing my line like normal, -x minus 4. So my y-intercept is at -4. And my slope is -1, so I'm going down 1 and right 1. And I'm going to draw a couple dots to make sure that I get a straight line when I draw this, because I don't want to erase something that I need to keep. Okay? And then I look at my interval. So this is when x is less than 0. I want to erase everything that is not where x is less than 0. So that's, I'll use this laser pointer. This right here, everything on this side needs to be erased. And then this point right here, x is 0, since there's no equal to sign, needs to be an open circle. All right, my second line, y equals x. I'm using a blue line, so that's the y-intercept 0 and slope of 1, so I'm going up 1 over 1. And again, I'm going to draw my whole line and erase what I don't need. Okay, so my interval, x is greater than 0 or equal to. That means I'm erasing everything that's below 0. So I'm erasing this part of the line right here. Because it has the equal to, I could leave my closed point at 0. All right, so now I want you to pause the video for, let's do 3 minutes and work on the practice problem. Pause for 3 minutes. Oh, just kidding, don't pause. I forgot that I have to answer the questions about this one. So I have to find domain and range first. Domain is the set of all x values. So when I talk about x values, I'm talking about that horizontal axis. I'm looking from left to right. And if I look from left to right, I'm going to trace this. I have a point everywhere here, right? And then I jump up here, and I keep going, and I still have a point. So because I have a point at every x value, then the way I'm going to word domain is all real numbers. and I still can use my symbol. You may also see it written as negative infinity is less than x is less than positive infinity. They both mean the same thing. It just means that you're hitting every x value. Alright, my range is the set of all y values. So again, taking my laser pointer, I'm looking from bottom to top. Notice how right here, there's nothing here. So my range doesn't start until right here. And then as I move forward, I'm going to keep going up forever, which means that my y values are only greater than this bottom point, -4. And you follow the same rule. If it's an open circle, there's no equal to sign. If it's a closed circle, there would be. Okay, and then we're also going to look at end behavior. So as x approaches -infinity, my left tail is going up, so y approaches positive infinity. And then as x approaches positive infinity, my right tail, that tail is also going upward, so y is approaching positive infinity. With piecewise, you can have facing different directions. Absolute value, they're always going to face the same, but with piecewise, they could be one positive, one negative. Okay, now pause for 3 minutes and work on the practice problem. Okay, so you should have paused and worked on your practice problem. We're going to check it together. So, first equation, x plus 1, that's a y-intercept of 1, slope of positive 1. Okay, so I'm drawing my line. Okay, and then x is less than or equal to 0, so I'm going to erase everything that is above 0. And I'm going to leave that closed circle since it has the equal to. Negative x, I have a y-intercept at 0 and a slope of -1. So I'm going to draw my line. And then that's when x is greater than 0, so I'm going to erase everything that's below 0. Alright, describe domain and range. So looking here, if I take my laser pointer, or you take your pencil, and you trace from left to right. Oh, let's go back. I made a mistake. Hopefully you caught my mistake. I should have on my second equation, since it doesn't have an equal to sign, that should be an open circle. I hope you guys caught that. Okay, now domain and range. So if I take my laser pointer and I look from left to right, I'm hitting a point at every value. So my domain is all real numbers. Okay, range. If I take my laser pointer, I look from bottom to top. So I'm going up, 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 up. I jump up to this point, and then I stop. Which means that all my y values are less than that point at 1. And it's got a closed circle, so I have the equal to sign. Okay, end behavior. Keep it on the screen so you can see it. In behavior, as x approaches infinity, so that's my right side, positive infinity. Y approaches, it's going down, so negative infinity. As x approaches negative infinity, that's my left side, it's going down, so again, y approaches negative infinity. Alright, now the last thing with all of this is putting together everything from 1.6 and 1.7. So if you think back to the beginning of the lesson, I said that absolute value functions can be thought of as two lines, right? Which means that I can write an absolute value function as a piecewise function with two lines. There's a formula that your book gives you. It's right here. There's this too, but this one, if you want to memorize it, if you're really good at memorizing formulas and it helps you, then go for it. I'm going to show you how to do it without memorizing so that you have one less formula that you have to memorize. All right. So for our example, we're actually going to do it backwards. We're going to start with the graph and then write the function. So I am just doing what I did in 1.6. So I'm finding my vertex. For this one, that's going to be at the point 3, 0. And then I'm using a table to find my other values. Okay, so when I plug in, absolute value of 1 minus 3, it's going to be positive 2. Absolute value of 2 minus 3, it's going to be positive 1. And then we mirror. And if you need to work it out, work it out. All right, so we plot our points, vertex at 3, 0, 2, 1, and 4, 1, and then 1, 2, and 5, 2. And be extra careful on these. Don't do a super janky line like I just did. Make sure it stays going in the path that it's supposed to go in, because you want to be able to see your y-intercept especially. There we go. Okay. Now we're going to write a piecewise function. So g of x equals, I'm going to separate this into 2 lines. My first line is this part right here, the left side. I'm going to write the equation for that line. So I'm going to find the slope and the y-intercept. My slope, you can pick any 2 points. I'll do the ones that I plotted so I know for sure I'm doing it right. I go down 1 and then right 1. So my slope is negative 1. So we have got negative x. And then my y-intercept crosses right here at the point 3. So plus 3. Then we've got to write our interval for it. So if x, and notice how we're looking from our vertex, like this invisible line right here. This line is on the left side, so that's when x is less than our vertex at 3. All right, our next part is this line right here. So my slope, I'm going up 1 over 1, so my slope is positive 1, so I'll have positive 1x. And then if I were to keep going with this line, following the same pattern, then my y-intercept would be at negative 3. So minus 3. And then our interval for that is if x is, we're to the right of our vertex, so greater than 3. And that's my piecewise function. All right, I want you to pause the video. We'll say 7 minutes. Pause the video for 7 minutes to work on the next 2 practice problems. All right, let's go over these practice problems together. So, first one, my vertex. There's nothing in the absolute value, which means that my x value is 0, and then y is negative 1. We fill in our table. Okay, so absolute value of negative 2 is positive 2, minus 1 is 1. Absolute value of negative 1 is positive 1, minus 1 is 0. And then we mirror. And then we plot our points. So my vertex is 0, negative 1. We got negative 1, 0, 1, 0. And then negative 2, 1, 2, 1. Okay, so we've got our graph. We're going to now write our piecewise function. So y equals, and you'll just use the same as whatever's over there. So the last one, it was g of x. This one's just y. My left side, my slope is -1, so negative x. My y-intercept is at -1, so -1. If x, and we're on the left side, so we're less than our vertex at 0. Okay, my right side, I've got a slope of +1. Same y-intercept at -1. And that's to the right, so that's if x is greater than 0. And then something I didn't mention before, the vertex is obviously included, right? It has a closed circle. So I need to make one of these have the equal to. So also go back to your example. Typically it'll be on the second equation. But as long as you make one equal to, then you're good. All right, now the last practice problem, my vertex is at the point 4, 1. So in my table, I've got 4, 1, and then surrounding it, 3, 2, and 5, 6. So you're probably going to have to draw this, or write this out to simplify. So if we have 2, and we plug it in, that's going to be 2 times the absolute value of -2 plus 1. Please make sure you do not distribute into the absolute value. Remember what I said about absolute value bars being like a fence. You can't get past them. You can get rid of them, though, by taking the absolute value. Okay, so when x is 2, y is 5. When x is 3, we'll simplify that. Then y is 3, and then we mirror. And we're going to plot our point. So 4, 1, 3, 3, and 5, 3. And then 2, 5, and 6, 5. I'm going to go ahead and keep going this way just to make sure that I go through the right y-intercept. All right, so now y equals my piecewise function. My left line, I have a slope of down 2 over 1, so -2. And then my y-intercept is at +9. And my interval for that, the left side, is less than your vertex at 4. Okay, my right side, my slope goes up 2 over 1, so +2. And then if I were to keep going, so I'm going to go back 2, down 2, back 1, until I cross the y-axis. Then I'm going to cross at -7. And that's over the interval where x is greater than our vertex, 4. And we put the equal to sign there. All right. If you guys have time for the rest of class, you will work on your homework. So I'll scroll back up so you can... Oh, no, I didn't put it in the slideshow. Never mind. Look at the whiteboard for your homework. So you have a few questions for 1.6 and then a little more for 1.7 since it's a little longer. Your homework is due next class, and then you have a quiz the class after that. So we're reviewing next class.